Hello, my name is Robert Smith, and I'm with New River Community College. And today we're just going to identify what systems are buffers systems and what systems aren't. Um, I have listed here three different systems. Um, the first one is aniline and aniline hydrochloride. The second one is uh, hydrogen cyanide or hydrocyanic acid, otherwise known as, and sodium cyanide. And then the third one is um, nitric acid and potassium nitrate. So let's get started. All you have to do is identify whether or not the species that is listed has a weak acid or a weak base and its conjugate. So in the first one, we have aniline, which is a weak base, and aniline hydrochloride, which is the ionic. It's coupled with a chloride ion, but otherwise, if you remove the chloride, it's the conjugate acid of aniline. So this one is in fact a buffer system. The next one is hydrogen cyanide or hydrocyanic acid and sodium cyanide. And this one, hydrocyanic acid, is a weak acid, and cyanide is the conjugate base of that weak acid. Uh, it may confuse you a little bit to have that sodium there, but typically you can't have a solution where you put an ionic species into it. You don't generally have every ionic species has to be paired with something. So that's why we add the sodium in the case of this, but it could be any alkali metal that we want to put there, we even could put ammonium cyanide, which is a monovalent cation. So this one, because hydrocyanic acid is a weak acid, this one too is a buffer system because we have the weak acid and its conjugate. Previously with aniline, we had a weak base and its conjugate. In this last one, we have nitric acid, which is a strong acid, and the nitrate ion is its conjugate base. So it's going to be very weak. So we do not have a buffer system with this last one. So basically for buffer systems, you'll want to know what your strong acids are and your strong bases are so that you know which ones are not going to buffer well. And you'll want to kind of have a rough idea of what your weak acids and weak bases are. And of course you can, the common ones you'll want to know, like acetic acid, ammonia, things like that, phosphoric acid. But some of the more exotic ones like phenol or benzoic acid or ones like that, you won't necessarily have to know. That information would be provided to you, or you can refer to a table, and that's often the case as well. And the other instance where you wouldn't have a buffer system that I did not include here is when you have perhaps a weak base, but you don't have its conjugate, or a weak acid, but you don't have its conjugate. It's a system where you have two completely different species in solution. So it's good to be able to identify what is the conjugate acid of a weak base and what is the conjugate base of a weak acid. Play around with that. All you're doing is removing or putting on a proton, a hydrogen onto the equation. So just kind of get familiar with that. And as long as you're able to definitively say whether the parent species is weak or strong, then you can and then identify the conjugate for that parent species, then you should be fine in determining what is a buffer. Okay, thank you so much.